All right, so we've already seen problems where we had to do operations, and we've already seen problems where we had to do composition. And so the big theme of this video is that we can do those things in the same problem, and we just want to go through the order in which we do them. So if you notice in each of these problems, there's an operation involved with one of the compositions and not the other. And then the last one that we're going to do, there's actually operations involved with both. In all of these cases, we want to perform the operations first. So I'm going to do r plus t. Then I'm going to compose it with t of x. That's like the last thing in PEMDAS now. So we're going to put that right at the end and say, simplify each of your separate operations, then compose at the end. So in this case, it's saying r plus t. I'm going to go up to my r and t functions, and I'm going to say that means x squared plus 5x plus 6. I'm going to put that in parentheses, plus x plus 3. Okay. So if I simplify this, it turns into x squared plus 6x plus 9. That is the sum of r and t. And then what it's asking me to do is to compose that with t of x. Okay, well, t of x, what this means, if I take something and I ask you to compose it with t of x, I'm saying go get t of x, here it is, okay, plug it in everywhere that you see x. So I'm going to do that. We're going to say x plus 3 squared plus 6 times x plus 3 plus 9. Okay, so again, I'll let you go through. You should know what x plus 3 squared means. It does not mean x squared plus 9. It actually means multiply x plus 3 with itself. And we're going to get x squared plus 6x plus 9. That is the square of x plus 3. I can distribute, and I'm going to get a 6x plus 18. And then I have this 9 sitting there at the end. Okay, so the last step is just going to be to combine like terms. Looks like x squared. I have two 6x's, which makes a 12x. And I have 9 plus 18 plus 9. Well, that's like 36. Okay, it's like 9 plus 9 is 18 plus another 18. So I'm going to say r plus t of x composed with t of x gives me this new expression, x squared plus 12x plus 36. Okay, so let's try that with a new one. So the second problem is doing the same thing. I have an operation division in the first one. So before I even bother with this composing with w of x, I'm going to simplify this. So we're going to say, all right, t of x on top, well, that's an x plus 3. Before I even put the w on here, let me factor it. It looks like it factors into 2 times x squared minus 9, and x squared minus 9 factors again into x plus 3 and x minus 3. Okay, and so I'm doing that work up here, so if I ever need to use w again in a division problem, it's already been factored, and I can just use this version. So I'm going to place that on the bottom now. That is 2 x plus 3, x minus 3. And if you remember, the rules say that if anything matches, cancel it out. And it looks like I have an x plus 3 and an x plus 3. So this is going to turn into 1 over 2 times x minus 3. That is the result of t over w to the x. Okay, so what we're going to do now is compose this expression with w of x. And what that means is take w of x, which we have the unfactored form right here, plug it in wherever you see x and simplify. So let's move it down a little bit and plug in. So now this is going to look like 1 over 2 times w of x, which is 2x squared minus 18, okay, minus 3. Okay, so what I did was I took the bottom expression, right, this is all got a big parentheses around it, and I put the x right here, and I put 2x squared plus 18. It's tough to see that 18. Okay, and now I just need to simplify again. So again, I'm going to combine like terms here. This looks like 18 minus 3, 1 over 2 times 2x squared plus 15, and you can either leave it unsimplified like that, or we'll distribute here. That looks like 4x squared plus 30, and I'd say that is the, after I divide t and w and then compose another w into that, this is the resulting expression. Okay, last problem, we have actually two sets of operations. I need to do r minus t, so let's go back up to the top. R is x squared plus 5x plus 6, okay, and I'm subtracting t. I'm sorry, subtracting t, which is x plus 3, okay. And be careful, the minus sign applies to both of these. So this is first expression is going to turn into x squared plus 4x plus 3, right? That is my first expression. Okay. The second one says do 2 times x plus 3. I'm just going to kind of do this right here so we don't clutter too much. Okay. That's going to turn into 2 times x plus 3. Well, that's 2x plus 6. Okay, so this right, is what I'm going to compose into the first expression. So everywhere that I see x in the first expression, they want me to put a 2x plus 6 there. Okay, so let's move down. Okay, so I'm going to take the 2x plus 6 and I'm going to plug it in right here and right there. It's going to look like 2x plus 6 squared plus 4 times 2x plus 6 plus 3. Okay, so again, we have to go through the process of FOILing. This turns into 4x squared plus 24x plus 36. And again, if you're unsure where that came from, just off to the side, do a 2x plus 6 times 2x plus 6. That's what squaring 2x plus 6 means. That's where I'm getting this number from. Okay. Distribute the second one, 8x plus 24, and then I have this stray 3 that's sitting there by itself. Okay, so I just have a big combining like terms problem. 4x squared is my only squared. I have a 24x plus 8x, which is 32x. I have 36 plus 24, which is 60. 60 plus 3 is 63. Okay, so don't try to factor this or break it apart anymore. We're going to leave it just like that. We're going to say r minus t of x composed with 2 times t of x is this expression right here. That is the final answer, and that is the summary of operations with compositions. Simplify your operations, then compose the two resulting expressions.